My name is Andrew Collin, and I'm working with Brian McNeil's group at Strathclyde University on free electron laser simulators. Simulators need a lot of parameters to be set before they produce sensible results. I'm going to show you a graphical interface that helps you set the parameters, avoiding unnecessary work, ensuring correct spelling and minimizing errors. As an illustration, I'll be using two simulator modules known as Generator and Astra. These were written at the Deutsches Elektronensynchrotron, often called DESY, and are in the public domain. Here is the entry screen for the program. The system will support many users, each with a distinct set of initials. On this occasion, I'll call myself AC. AC. And I haven't used the system before, so I'm a new user. I'll go on to the next screen. The system now moves to a screen where you can set up a mimic diagram. First, you must create a new configuration. The system will name your configuration automatically in a way you can easily retrieve it, but you can add a short comment if you wish. New configuration, and the extra comment will be AC's first. AC first. And you can see the configuration name has appeared up at the top at the right. Now we can populate the screen with our simulator components. So I'm going to use, first of all, a generator component to produce an electron beam, then an Astra component which will accelerate it to high speed, then a MASP component which will condition the beam suitable for the FEL simulator. Next, the Puffin FEL simulator itself, and finally, since the Puffin outputs a high energy beam which is not required for anything, a beam dump to put it in. Now, of course, we haven't shown the connection between these items, but we can do that just by drawing links. And as you can see, they're not straight lines. They don't they're not meant to represent beam guides. They're just a symbolic indication. We also need to add some measuring components, and we would normally use the visit system, which is also in the public domain, which plots graphs. And I'm going to connect one of these up to Puffin, so we can see what Puffin is doing, and one up to Astra. Now, at this stage, the configuration is completely flexible. You can move the components around, and you can also add new components or delete components as you wish. Once you have fixed your configuration, you can save it, and which means you get it back if you want to use it again later. I'm going to set some parameters for the Astra module. Set parameters for this module. Now, the point about Astra is that it has a very large number of parameters, and they're divided up into separate groups or name lists, and they come in two sorts. First of all, we have name lists which only occur once for each definition of parameters, and these are listed on the left. And then you have name lists which may occur several times. For example, in an Astra simulator, you may have several quadrupoles. I'll start by putting in some parameters for the neuron name list. Now you can see that there are several types of parameters. These, by the way, are not all the parameters. They come in several pages. But of the types, first of all we have a Boolean or binary type where you simply select yes or no. We have a numerical type where we can enter a number. I'm doing these at random, of course. And then we have a string parameter, which could be a file name. And I can put something in there. Anything. Now the values you see before we start are the default values, and if you're content with the default values, you don't need to do anything at all, you just leave them. I should mention why some things are on the left and some on the right. On the left are all the parameters which the system needs to know, even if they are the default values. On the right are values which are only required for certain combinations of inputs. For example, at the moment we have specified that we don't want to use RMS values. But if we do want to use them, immediately you get here some more parameters which you can then fill in to whatever values you want. We might go on to the next page and there are some more parameters. And the next page as well is quite short because we're near the end. And then we return and as you can see, the system now remembers it's got some parameters for the new run system. The parameters for the multiple components work in very much the same sort of way, except that you can enter many name lists for each particular type. When you have finished, yes, one point I should mention is that if you don't know what a particular parameter means, you just ask in one of these query boxes here. What does that mean? Well, that's what the run number is. If you don't know what that one is, you can find out. These comments are of course copied from the Astra manual. So if we return to this page, these queries also exist for groups. So if you want to know what the scan parameters are for, that's what it does. I'll now return to the mimic diagram. We're back there. We can, at this point, once we're content with parameters, we can save them, and then when you save them, you can then take that file and use it as input to the appropriate simulator. To end this demonstration, I should tell you a little bit about the work in hand. We have yet to drive the simulator modules from the name lists that the system has set up, couple the visit module to show useful results, and manage the handshaking between modules. Our plans include being able to use simulators on remote, high-powered computers as well as locally. Thank you for your time.